Swayam Prabha. Digital India. Educated India.
How do we capture the ideas and how do we convert them into our intellectual property? So that is the critical aspect, which is very, very important for us. Which is what we're going to work on and do. So I've started my airplane mode. Sorry about that. So here we are looking at those important critical domains, let me quickly take you forward from here. So all my now nearly 4 decades of teaching experience have culminated in this very interesting Indian ethos of concerns for innovation. You have to be concerned for your user. You have to be concerned for your manufacturer. You have to be concerned for your seller. You have to be concerned, and those concerns result in innovation. And I'll take you through the my friends call me Chakku. So these are the Chakku's 7 concerns for design innovation. And each concern, I'll show you one product, and I'll show you the design registration for that and the story behind it. So that is the way I'm taking my whole presentation forward. So the first one is you stand for a cause, which is the first concern. That is you say that you take a resolve that you're going to solve a problem. So that problem was that the students had to go and identify the problem in the field. In blood banks, they found out that's very, very difficult to prick and get the vein for some patients. So here we came up with this very simple device, which is the vein tracer. This device took us nearly 1.5 years to build. You see the form factor over here. This form is the 4th iteration of form, and that's the pilot production. It's very, very convenient to use. The form is shaped in such a way that's easy to hold and easy to use a syringe to draw the blood. So all those factors now are very critical. And now we need to take this to market, right? If you have to take this to market, I need to have a design registration, because patent is not possible, because it's just a simple technology, infrared technology, which highlights oxygenated blood. So from that point of view, I can't get a patent. So you could, but whole aspect over here is about the design registration. And we of course have this wonderful design registration where it is called just the vein detector. It is not even called user friendly, because as soon as I call it user friendly vein detector, it goes into patents. It is just called a simple vein detector. And this vein detector, what is the patent, which is the design registration, which is done, is just the shape, colleagues. And it's just very, very easy to do. I must tell you a small story over here. As part of the Indian knowledge systems, we were of the opinion that, oh, we'll keep on producing new products and we'll keep on putting them in the market, but we're not going to be, bothered about, patents. So when we started our project, we just kept on delivering, ideas and products and systems. And then, very interestingly, Ministry of Education came back and said, we're going to do ranking. And the ranking of the design innovation centers will happen as per the number of patents and design registrations. And then we were ranked out of the 20 design innovation centers set up in the country. I was ranked around 3rd from the bottom, because I had that time only a couple of design registrations. So that's where, when we seriously worked on this, it's very important to have a design registration. You can have a philosophy that you keep on building new products, but that is not enough. You need to be also recognized. You need to also safeguard the people who take your designs to market. So from that point of view, these design registrations are very important, and they're very, very simple to make. I'll show you in detail in the next slide how we make these very simple design registrations. So these things actually are critical for us, and we are just seeing how we are going to, take this forward. So now that was the first, design registration we did. So let me take you to the next one, which is our the context. A lot of people build very interesting ideas, but they're not contextually placed to the right environment where it's going to be used. So this becomes very critical. For this context, I took a very interesting, example of designing a water bottle for CRPF Jawans. Again, the problem came from the field where Jawans actually have a lot of problem of drinking water when they're in the forest, and the drinking water bodies are poisoned sometimes, and they need a very, very good source, and they also did stay in the forest. So here we built this wonderful project. Let me play the video for you. Bottle was designed as participatory design using collaborative, innovation model, which I built. Around 8 teams of CRPF Jawans were partners in this. And the type of insights we got from them was phenomenal. And the context of where it's going to be used is the paramount. For example, this doesn't need to have a transparent, strip to see how much water is there, because water is precious for the CRPF Jawans. So they will drink water as ration. So there's no need for how much water for them to check how much water, because by the weight itself they would know, because that's dear to them. So these are those interesting insights which made the bottle very robust, which made the bottle very user friendly, and of course the filter is integrated in the bottle itself. And we again got a design registration for that, and like we could have got a patent also for this, depending upon how we place the filter, but that was not too much of novelty because filter is just placed in the bottom. So these interesting things which happen. So here also we got the shape registered, because the type of bottle had the special bean shape, and it was very easy to hold while you crank. So the form was having its meaning, the form was having its ease of use, the form was having the filter integrated in the bottom cap. So all those form factors became critical for us in the registration. So now let me come back to my third, concern, which is the comprehension. Generally, when you actually do a lot of survey, and when you talk to users, customers, and people, you get a lot of insights. You need to convert those insights into features in your ideas, or build itself upon the insight. So that becomes a very, very critical thing in the design phase. And here, for example, we have we had this problem of why don't people use solar ovens? There's so much heat. Currently I'm in Hyderabad. Oh, I'm like enjoying the Hyderabad heat because my cooking happens much faster. See how the heat is no longer troubling me, because it's cooking my food much faster. So these are type of things which happen. So when we went to Bombay to survey, they all said that it's so inconvenient to go outdoors and cook. So we built this wonderful solar oven, again a student project to pilot production, and now getting into a startup where you actually mount the oven in the window, the sun side of the window of the house, and use it from inside the house as a microwave. So you have the convenience of a microwave, and you have the mounting as the air conditioner, window air conditioner. And we use very, very high technology here, from chemical engineering to the thermodynamics to material science coatings to material dimensions. So it's very interesting that this greenhouse solar oven is very, very convenient to use, and it's also very viable. So I'm going to show you in detail how the patent worked over here. Let me quickly show you a small film to see how we took it to market.
The Design Innovation Centre at IIT Bombay supports the best design minds in the country to conceptualize, prototype, test, and ultimately produce innovative products which will enrich our lives. Our student Avinash found out that the conventional box-type solar cooker is very inconvenient to use. He came up with this new design of window-mounted oven where one can operate the oven from indoors. We receive ample sunlight in our country, and the solar oven takes us a step closer towards a sustainable lifestyle. This versatile solar cooker with zero maintenance can easily recover its cost in a span of 3 to 4 years. The multiple advantages of our solar oven are that it cooks for free, it cooks nutritious food, and the food is tastier.
As an athlete, I always have to perform at my peak. The key is to be dedicated to the idea of fitness. That also means I need to watch what I feed my body.
एलपीजी की सब्सिडी काफ़ी कम लोगों को दिया जाती है, इसी वजह से खाना बनाना काफ़ी महंगा हो रहा है। आजकल मैं सारा खाना सोलर ओवन पे ही बना लेती हूँ, तड़का बिड़का गैस पर लगा लेती हूँ।
The solar cooker uses renewable energy of the sun and therefore conserves fossil fuels. We have cooked rice, we have cooked millets, various kinds of curries, vegetables, khichdi and things like that.
Because of the lower temperature, the nutrients in a food are more stable compared to other methods of cooking.
The cooking is done in the juices of the food itself, and all this contributes to better retention of fragrance and a tastier product at the end.
Fabulous.
The solar oven has gone through many stages of evolution, from a design idea to pilot production. We did multiple tests to improve the efficiency of the solar oven. Thanks to the collaborative efforts of our Design Innovation Centre team and the professors at IIT Bombay, we are at the verge of delivering this amazing product from our drawing boards to your homes.
So we are, thank you so much for the appreciation. So this basically the design happened collaboratively. That's Professor Kedar, who is currently the director of IIT Bombay. He was our advisor on understanding the thermal aspects, the calculations and all. And what is surprising is the solar oven, that was the first model, which was a round model, which was done by student Avinash. Avinash also joined back with us to work on the project. So it was the best thing to do. And we built the whole product. And we found out that the convection was 65% and conduction through the plate, which was there in the solar oven, was only 40%. So we really shrunk the volume of the oven so that the air can get hot faster. So let me show you another interesting insight I want to show you about entrepreneurship, because all intellectual property knows about entrepreneurship and market. We were in Surat and we were saying, we have this micro solar oven which can, cook anything from cakes to, it can do rice, it can do dal, it can do sweets, it can do khichdi. Then this business guy said, if you don't have a focus on what your product can do, you cannot sell in the market. You just call it a rice cooker and I'll order 100 of them right away. So then we called it Sunrise, and that is what you see in the picture with Avinash. So it's very interesting to be focused in your design. Of course, when they bite for rice, they can do whatever other things you want, but you have to be very, very focused, like the cause, that what you're solving. And let me now quickly explain to you the design registration part. In the design registration, you just have to give 7 views. These 7 views are sent. They have to be neutral without any graphics. So the front view, the back view, the left view, the right side view. Look at this box. This box is the box which is needed for you to fit into the window. So this is part of my oven accessory. If I don't add it in my thing, then I won't be able to do a separate design registration for that. So the box which is fitting my oven and this box goes and fits into the window is what is the total design endeavor. And we need the top view, the bottom view, and the perspective view and the other perspective. With these views, we got the design registration done, and it is just designed registered as design or window mounted solar oven. So here, luckily, they were asking us to just call it solar oven and the window mounted. It's very interesting when you have a function in the form. They don't accept in design. We're very lucky that they accepted this, this name. They would just call it a solar oven because window mounting is a function and that will have to go to a patent. You got it. So those are the interesting situations. But luckily, the attorney agreed in this case. We had a couple of extra meetings, and then we said that the whole form itself is built around being on the on the window. So then he agreed that because we had the bracket also, they finally agreed. Otherwise, they wouldn't have agreed for this. Now, this particular design also is patentable. So what would you do for patent? Of course, for the patent, you have this wonderful, greenhouse effect. There are two polycarbonate shells. It's a double-walled, transparent shell, and that shell has got a rounded shape, so the sunlight can come from all sides, and it has an optimized cooking tray for high tea temper. This is a tray. In fact, colleagues, I must tell you, the success came because of the tray in the oven. The greenhouse effect improves inside, but if you don't have a tray which can take all the heat, so 40% conduction, I was telling you, 35% conduction, that conduction tray was very important. And the coatings for the tray comes from Nagpur, professor who works in the in the cook stove area, and so that coating improves the efficiency by another 15%, the black coating. So this optimized cook tray is very, very critical for the heat transfer in all seasons. And of course, we have to make the clear drawings, show all the specifications to get the patent for this. And the air gap dimensions also important. And when we did the prior art, we had a lot of projects which are window mounted. Like there were these glass boxes which people mounted on window, and they said, we've also done it. But luckily, because it was not just a glass box, it was there was a involvement of how the gap was giving you the greenhouse, how the polycarbonate was giving you the right transparency and the right enhanced insulation was all considered. And and of course the optimized tray. You see the flanges of the cook tray, colleagues. These flanges were black flanges which actually would absorb the heat from the side also. So you're going to maximize the heat absorption over there. And of course, we're very happy that we got this patent. It's called the window mounted solar appliance. And colleagues, I'm very, very happy to inform you that we also got the international patent in 4 countries. We saw where all the sun goes. So in the US and South Africa, in Australia, we took a patent in all those areas. That's another very long process. That had been very tedious. Till the patent itself, it takes a lot of effort. I would like to advise all of you to really, have, special project associates who work on this, because it's a full-time job to, take a couple of projects to patent forward. And of course, if it's international, you should have the money also through projects as well as the, thing to take it forward. So now, that brings me to my, 4th C, which is the check. Again, colleagues, a very, very interesting thing. When you say check, you have come up with some insights. So you have a checklist with you. When you make ideas, products, and systems, you have to go back to see whether you are really satisfying all those aspects. That's why we call this the check. But actually, it is, creating a product brief. So I got this very, very challenging, wicked problem of creating a palki for Vaishno Devi Yatra. So there are these 4 porters who carry, pilgrims on the hill. Let me quickly show you the video so you get a good idea.
श्री माता वैष्णो देवी श्राइन में पहुंचने के लिए बहुत से साधनों का प्रयोग होता है, और उन साधनों में पालकी एक बहुत महत्वपूर्ण साधन है, और जिसका उपयोग जो है हमारे जो अशक्त और वृद्ध लोग हैं वो करते हैं। लेकिन इस पालकी को कैरी करने वाले पोर्टर्स की बहुत सी परेशानियां हैं, क्योंकि इसका पालकी का वज़न काफ़ी होता है, और 13 किलोमीटर के इस ट्रैक पे उसको ले करके जाना एक काफ़ी पेनफुल मैं कहूँगा कि काम है, जिसको इम्प्रूव करने की ज़रूरत समझी गई।
Our role in this project was to do a very good user study, understand the needs of the porters very, very closely, and come up with designs which will help them to reduce the drudgery.
This is the prototype we built in our own product development cell in IIT Bombay. We got a very expert welder, because when you build prototypes and to go to field, you would have very good welders.
While IDC put up a design, we came up with ergonomic studies, their biomechanics system, where the load is coming. We found the shoulder and back were two areas where the lower back was two areas where a load was very heavy, and we looked at how we can reduce that load by doing proper design.
The final design was lightweight and robust. We could reduce the weight to 34 kilos from around 50 to 54 kilos, and this made a large impact on the comfort of the porters. At the same time, we were very focused on the structural analysis of the palki, and we conducted the analysis that we managed to maintain very good structural stability and structural integrity in the design so that the palki can last long and it can be very safe.
Today I am very happy as these integrative efforts are being concluded, and final solution is emerged is lightweight, ergonomically designed, safety aspects are there, all the designs are structurally validated.
Another, a very collaborative project, and I'm so happy to mention that I had to bring the porters from Vaishno Devi, and they stayed with me in the hostel. We paid them their salary so that they don't lose their daily wages. And for example, it was a complete participatory work, because they're so used to these palki that any of these designs we were doing, we were failing. We had actually failed on 8 palkis before this, and this is the final success. And again, like we always say, that there's always blessing from the Mata Vaishno Devi. Jindal sponsored 100 palkis, and 100 palkis are now flying, and there's not even one failure. Over the last 4 years. Earlier, every 2 weeks, one palki would break. So that's the beauty of how you could use structural analysis by my Professor Desai from IIT Bombay, using ergonomics from Niti by Karuna Jain and Rauf Iqbal from their team. And of course, I had a team of another 4 or 5 project staff and associates working together to build this product. And it's very interesting that nobody is concerned about this product other than the principal scientific advisor, Chidambaram. So he said that we need to do something for the porters, because we keep rules saying that they can't charge extra money, but we also have to give them facilities. So and this has been my childhood dream, that I should do something for the porters, and I'm so happy that we could do it. And we also have and of course you see these 400 palkis, 400 porters. Very, very happy. We had to do it. There were some 400 porters, so we had to draw lottery to give the porters the palkis. And of course, you can see this, palki being used. Anytime you visit the place, you'll be able to see the palki moving. And we have a design registration for the palki, and we actually dedicated the all the intellectual property to the shrine board, saying that we will not need any royalty for such a project which is for national good and national cause. But see, colleagues, design registration is important. The design has to be identified between NITI, IIT Bombay, and my professor from structural engineering. So all our names are there, and IIT Bombay's name is there, and NITI's name is there. So that registration is an important contribution to the nation. Because it adds up to the design registrations and patents. So we have to make up, our understanding. In fact, I was also very naive earlier with all these things. We have to really go forward in our index on how many design registrations we can come up with and improve our, rating in the country. So this is an interesting case where building ideas is very important. So like in all the projects, all the 6, 7 C's are there. But I'm just showing one project to highlight that aspect was very critical here. So one of my students' friend died in a motorcycle accident, and his helmet was strapped behind. Because his helmet was full face helmet, difficult to wear. He didn't even wear the helmet, and he had head on with a truck and he died. So this same student, I made him work on a helmet, saying that, come, let us make a helmet which is easy to use, you can grab and wear, and it's easy to store. So that's the project over here. easy to wear helmet. The student is currently the head of the design program. It's BIT School of Design in Mumbai, Mandar. Kale. So wonderful ideas we made, from folding to opening to ventilation helmets, and finally we came up with the 3D printed mock-ups and prototypes, and finally we have the prototype of the helmet, looking for manufacturers to take it to market. So the whole and then very interesting elastic to hold, so that people found it very difficult to even buckle. So we have just a very simple skin friendly elastic which is used in undergarments, so that you can also wear that very easily. So that, and this also got a design registration and patent. Now comes to the sixth C, which is crafting. I'll again show you in detail, colleagues. This is again a very challenging challenging project, because once you make ideas, you also build models and build designs. So in this case, we built a letterbox for the country. We failed 100 letterboxes we made in stainless steel, and we put it all over the country, and we realized that people are not able to recognize it. And then we designed the newer one, where the PM also appreciated the box, and now it's in the production and used by India Post going forward. So this, very interestingly, we have a design registration again. The shape, see, what is the novelty here is the shape. So we have the front view, the back view. This is the only submission we need to do. No graphics. You can't put any graphics. You just have to get the views right, and all the views, and then you have the design of the letterbox. Design registration, and so my last C, running out of time, is the connection, colleagues. So in the connection, what happens is you design a product. Remember my letterbox, when it went to the users, my connection failed. So I had to, connecting with the user failed. So went back and designed and redesigned to come back. So for the connection, I'm going to show you my 3 decades of work in petrol pump design. I was in Larsen & Toubro after graduating from IIT Bombay. So that was my first design, which is called the Z-Line petrol pump. Some of you would remember this petrol pump, which dotted across the country, and L&T did huge amount of business. And all these case studies in details are available on my YouTube channel called Innovation by Design, Professor B.K. Chakravarti. You could just Google and get the YouTube link to all my playlists. Please, have a look, and please use them extensively to showcase how design can go forward. I want to again credit my professors from my School of Design, my teachers, Professor A.G. Rao, Professor Atwankar, Professor Munshi, Professor Bapat, Professor Kirti Trivedi, Professor Ravi Puaya. They were instrumental. Professor G.G. Ray in ergonomics, instrumental in giving us the foundation in design, and and I want to capture all their learnings into these live projects, so that we can take these direction of creativity, building new products forward. This petrol pump, colleagues, just because I built this petrol pump in Larsen & Toubro, we kept American Gilbarco, which was 10 times more expensive than our pump, out of the market continuously. The story didn't end there. It's very interesting that now we have the competitor came to me as I joined IIT Delhi as a professor in 1994. He said, the product is now our product is obsolete. Now nobody's buying our product. And because, colleagues, we design registered this shape, because of the shape, the tenders were saying Z-Line petrol pump, and no other company was able to produce. So this is a very interesting case study of design registrations, where if the tender gives your design registration as their spec, how can anybody else supply any other product? So with single tenders, and all the pumps are supplied by L&T, and L&T made huge amount of money. Then we came back to our company called Midco, and this was my PhD topic. We designed the petrol pump as a student project to market. And colleagues, new technology, new materials, new situations. This pump completely wiped out the Z-Line pump. A small company, we call it serial innovation, can completely wipe out a large company if the product is not taking forward. Similarly, we do another project for Oval, and we did Showfill, and these are Showfill are still dotting all over the country and kept all foreign companies out of our country for 30 years. Look at the revenue which we could create and take things forward.
How can you motivate the students and extract the work from the student in order to get the registration and design and this patent also?
So very good question, Manoj. So what happens is generally when I teach a course on patent and design registration, I take up all the earlier students' projects and we actually design register them and design patent them. So through the patenting process, they learn and we give them 1% share in the intellectual property because it's business, right? So out of the 30 in my class, 2 of them got technology transfers. So so out of 32 people got money for their work. So we have to make it very live. We have to make it very entrepreneurial, and we have to say that there'll be some market somewhere for the technology. So what happens is we may not identify that as good, available, but the motivation, from point of view of market could be there. So, we need to convince from that point of view that you have worked out for a user because your projects are always user centered. So there will always be a need. So for someone somewhere across the world. In fact, earlier there was a company in Ahmedabad which was designing 3D models of patents so that they can be saleable. So patents also have to go to the next level so that somebody can see the product for it to go to market. So that's also one very important journey today. Thanks to CAD, thanks to AI, your patents all can be now embodied, and you can see a product out of it, and you can do much more selling. So you have to have a selling department also. We have a selling department in IIT Bombay, through our Dean R&D's office. So they actually promote through industries all the patents available. And sometimes we sell patents at as low as 50,000 rupees.
Okay, sir.
Technology transfer at 50,000 to small SMSC. MSMEs can't pay more than 50 to 25,000. Why should we ask more? Otherwise, my patent is lying unused.
Right, sir, right.
So we have to be really, really considerate with the industry. The challenge is sometimes we are not considerate with the industry and we are very selfish. That is the whole problem. And you don't give exclusive right, you give non-exclusive rights to the small companies so that they can take because there's so much work to take any design patent forward. It's not easy. Your patent is only 5% of the total work. So these are the motivations we need to give colleagues and students so that they can take things forward.